Preliminary evaluation of the manufacture of the packaging from the acid hydrolysis of the cocoa shells. The cocoa sector in Colombia has been growing in recent years due to national and international demand for this product, as well as to productive projects promoted by the government of the producing departments. Given the volume of the production which has been growing in the country, it is necessary to think about how to treat and manage the waste generated by this industry, taking into account that in the cocoa explosion only the seed is economically used, which represents approximately between 10% and 20% of the weight of the fresh fruit, while the rest of the weight on the fruit has little or no use the cocoa farmers. This means that currently tons of the waste are being produced that have no commercial value and have no important role in the supply chains. Even so, cocoa shell is a product that has great potential. Given the difficulty of the producers to make a compost to obtain fertilizers, many of them resort to simply stacking the shells somewhere in the crop. This practice is usually a key factor in the propagation of the Phytophthora fungus, which passes from the infected shells to the soil through the humidity that transports the spores, and from the soil it passes back to the cocoa plant, causing it froze to the dried and have a black coloring, which why is the disease is commonly known as black hair. The presence of Phytophthora contributes to the most of the losses in cocoa production compared to the other diseases, which implies that this pest in the cause of important economic losses for the cocoa sector, and it is necessary to plan and manage the waste as a mitigation measure for the economic losses generated by Phytophthora and other diseases that are caused by decomposition of the pile of crops. Another problem associated with cocoa waste management practice is that empty shells in rain seasons serves up water tanks that facilitated the incubation of eggs of the Aedes aegypti mosquito, which is associated with the transmission of diseases such as the dengue fever. Packaging extraction will be carried out on laboratory scale. Samples of cocoa shells will be taken from the area of the municipality of Fayón in the north of Tolima, in the village of Mondeco. Later, a pre-treatment of the raw material will be carried out, consisting of the drying the material and reducing its size. For this purpose, the different equipment available at the Universidad Libre Seccional Bogotá will be used to carry out the size reduction. The size distribution of the material will be determined and the appropriate fine practical size will be selected to perform the extraction of packaging by acid hydrolysis. The crucial variables of the progress will be determined experimentally: type of acid, citric, nitric and hydroxyl acids, and ethanol will be used as a precipitating agent dependent on the mode of extraction and pH, obtaining a different yield each pectin. So the pH 2.0 and 3.0. Temperature 18 and 19 C will be evaluated for a time of 19 minutes, thus which the greatest impact on the yield of pectin will be selected. With the extracted pectin of preliminary evaluation of the process to obtain pectin sheets will be carried out, as well as a preliminary characterization of its humanity percentage using infrared spectroscopy, and the functional groups present in the new material will be analyzed. Finally, the progress to obtain a plastic film from the extracted pectin using glycerin as a plasticine agent will be evaluated. This film will be tested on its physical, chemical, and biodegradability characteristics to evaluate its potentials use in packaging for the agro-food industry.